Hello, everyone, and welcome to today's SANS webcast, Exposed Industrial Control System Remote Services, a Threat to Critical Infrastructure, sponsored by Xona Systems. My name is Mary Lynn Gollier of SANS. Today's featured speaker is Ron Fabella, Field CTO at Xona Systems. If during the webcast you have any questions for our presenter, please enter them into the Q&A window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to our presenter.
Awesome. Thank you, Mary, and thank you, SANS, for hosting us. My name is Ron Fabella, Field CTO at Xona Systems. My background is in industrial, and this particular topic is especially important to me for a few different both experienced and seen concepts. And the idea of exposed either services or industrial services is something that comes up every now and again. It seems like every 10 years, someone discovers, or every few years, someone discovers Shodan or someone discovers something. And it's a huge problem that is still unaddressed in our industry. So again, my background started off in the Air Force, but fell in love with industrial control systems about 15 years ago. And I've done everything from NERC compliance, which is kind of the gateway to any industrial control cybersecurity for those looking to break into the industry. NERC is a great way of doing that in the US. But I've done penetration testing on oil rigs, power plants, manufacturing floors. And this idea of remote services is so critical to the attack path, attack surface analysis, and really the meat and potatoes of how can malicious or maybe even non-malicious actors actually disrupt our critical processes and our critical infrastructure. So I wanted to go over a few concepts around attack surface. And really the idea here is that a surface, when you think of any kind of system, is almost like this layer, this interactive layer, this bubble that humans or operators or anything can interact with another system. So just to level set a bit, you hear a lot in cybersecurity about attack surface. You may also hear some different, I would say, concepts such as the kill chain. This was something, cyber kill chain that was developed by Lockheed Martin and then extended into the ICS kill chain by SANS and some folks. And the idea here is that whether you're talking about the attack surface itself or the chain of events necessary to form up an attack, you're really talking about interaction with a system. Now, when we talk about attack surface, and I crossed it out here because you'll see in a minute why attack surface versus just surface and industrial, they're essentially one and the same. But just to, at a high level, and what NIST says is that it's a set of boundaries, or it's the boundary in which you interact with a system or interaction is possible. So keep that in mind. Anything could be an attack surface. If you're looking to break into a building, let's say, an attack surface could be the ingress, egress to the building, the doors, the windows, the dock on the back of the building. So just think in your head, attack surface or access surface are essentially one and the same here. And this is a particularly challenging concept when you talk about enterprise IT. The surfaces are so great in how we're able to interact and the different ways we can interact with systems is so much greater oftentimes than industrial. But for surfaces, the reason why I wanted to go down this route is to say, well, let's just put them into three categories, three big buckets. You have your systems, software, operating systems, applications. When you think of cyber attack surface, this is where your vulnerabilities or your exploits will come in. Oftentimes, right? If there's a CVE for an application or a piece of software, that could be part of the attack surface, right? Attack surface could be networks. So again, just logical access from either remote or even to the system right next to me via network. These are ports, services. These could also have vulnerabilities. Many CVEs, both in enterprise and in OT, you might have these insecure protocols that we often have in industrial, where you can just interact with that attack surface or that surface with the system through the ports and services that are available. The other thing to take into consideration is the people. Now, I'm not really one to be like, well, people are our weakest link and, operators, this and that. but people and user access to these systems is really what matters. What matters, whether you're IT, OT, or whatever, is these systems have to be used for their purpose. And what we say in industrial is that the power plant's not there to generate the cybers, it's generate megawatts. So people and user access to systems and networks is paramount. But I want the level set to say, this is really surface overview. They can be used for attack, and industrial, though, they're just used for operations. And that's something that's important. So some examples of industrial control surfaces or control surfaces. Here's an example of some systems. Now, operating systems, applications are the underpinning, but from an operational stance, here's a few examples. A human machine interface. Here's an example from TVA. They're my local utility, but they're a large utility, and they have a large river ops center. I've had the privilege of working for TVA for a short time, and they have these video walls everywhere to show control status of the operations. And humans, this is kind of very pedantic, but humans interact with the machine through a human machine interface. And think of this as it's a laptop, like how I'm interacting with you. It's a Windows workstation, oftentimes with a piece of software that interacts with the critical infrastructure system, in this case, hydro and river operations. These come under different terms. If you go into oil and gas, sometimes they're called OWSs, or operator workstations. And you'll hear the second one, which is engineering workstations, used pretty much across the board. The difference here is that one is an access plane. So I can go in and see status, I can do some control, can make sure the red lights are green and vice versa. But an engineering workstation is more of an administrative workstation where they can actually affect control or configuration change from this particular workstation. So these are just two. And I wanted to give a highlight here to the wonderful field manuals that Dean Parsons and SANS have put out, because there are many examples of different systems, networks within critical infrastructure. And these field manuals do a great job of going over everything you could want to know at both a high and detailed level about ICS security. So just because I didn't mention, DCS or OWS or EWS, historians, these are all things that are reviewed in the field manual, and a great way to start and understand the different systems that we're talking about in OT. So just a quick plug there for Dean and the crew. Love that stuff. Of course, networks as a control surface is something that is, I don't want to say new to OT, but you'll often hear that. You'll be like, oh, you'll go to a conference and they'll say the IT-OT convergence, and everyone throws up their hands like, this is a new thing and it's huge and it's a huge security risk. The secret with that is the networks have been converged. It's been a decade or two at this point, but at some point, whether you're running a power plant or a production line or you were refining oil, the business said we need to modernize. And they did that primarily either in hardware and software or in interconnectivity. So first they interconnected their process lines, their cells, their substations, whatever the case may be, and they created these networks or systems of systems. Now, depending on which vertical you're in, oil and gas, it's a process control network. SCADA versus DCS, you can get into theological arguments as to how they're different and what's different about them. But the idea here is that at some point, either in the not so far or near future, industrial control systems were modernized to speak to each other over Ethernet. And that's important because from an attack surface or just a control surface, industrial now inherited all of the crazy things that we can do from a cybersecurity stance from both attack and defense because they moved to Ethernet. And so this is a huge attack surface or surface within industrial control systems because of that interconnectivity. And as you hear and as you know, depending if you hear the myth of, oh, all these are flat networks or none of this should be connected to the internet, this is the crux of the increase in risk to our systems today. A note about enterprise. So it talked about the IT-OT convergence and the fact that essentially it's converged at some point. Enterprise, from a traditional, if you think of it as a bucket or a category of systems, like Windows workstations, Linux servers, routers and switches, even wireless. Within the architecture of industrial control systems, there are enterprise-like systems down the stack. And if you're familiar with the Purdue model, it gives this idea of there are different layers, And at the top, layer 5, that's your enterprise. And as you go down the layers, you get closer and closer to the critical process. Well, when you start at the top, the layers are very enterprise-like. They're performing an operational function, but they look familiar to maybe some of the SANS audience, right? Again, Windows workstations, et cetera. But as you go down, it gets more specific to the actual cyber physical devices that are, digitally controlling physical processes and that are remotely accessible. I'm going to use remotely in air quotes to the SCADA, the DCS, the PCN. So then that way the businesses and the operators could realize centralized access and control. So, but this is a huge control surface and one I'm going to focus on. But first, let's not forget about people. People use the systems and the networks in order to interact with these cyber physical processes. So they're very important in this surface overview because how they interact and the conditions under which they interact with critical infrastructure is how attackers will exploit to act on their objectives. So you have the operator. This is the generic, the user that is there for the purpose of making sure the process is running. They interact with all these control services daily. Now, another side of people, not just the on-site, you'll sometimes hear the term asset owner in terms of asset owner and operator. You also have a lot of third parties. Now, third parties in this sense is just anyone who's not an operator or maybe anyone who's not in the organization. These could be your vendors. There are managed service providers for industrial equipment, whether it's the networks or the devices themselves that may or may not have access, both logical or physical. The OEMs are the original equipment manufacturers. I hope I got the O right because I always forget. These are your ABB, your Emersons, your Siemens, your Schneider Electrics, et cetera. They're the ones that actually built the system. And let's not forget that when they build that power plant, there's warranties, there's services agreements, there's things that the OEMs provide to help maintain and maintain the efficiency and safety of that plant. All of this is to say that, and this is where people kind of get prickly, there's a lot of remote access to these systems, whether it's temporary or continuous, to support the function of operations. And that gets all us cyber people very anxious, right? But there's also then the IT folks within the organization themselves, which you could consider, I know the plant folks probably consider them third parties, but they're there to interact with the enterprise level systems that are down in the stack, the network switches, the firewalls, et cetera, and they're able to access and do configuration control as needed. So when we talk about surface, these are all things that are part of normal operations again, and are being used on a daily basis, but can be used from an attack perspective. I'm just going to pause to make sure there's no questions. Oh, let's go back and let's not do that. Let's click this. Perfect. So we talked about systems, networks, and people. Unlike enterprise, and I was really fighting the, let's take the CIA triad, confidentiality, integrity, and availability, and flip it on its head. That's kind of a common thing that I think I did early on as a cyber person. But really for industrial systems, it's a little bit different. It's really safety focused. That's number one across the board. It's about protecting human life. It's about protecting the equipment and the process. And then the environmentals around it, because when bad things happen in these systems, it has more than just a downtime on availability, which is why I prefer the safety moniker. Reliability could be associated with uptime, but really it's these physical processes. How reliable are they in producing the widget, producing the megawatt, cleaning the water on a daily basis? Because again, these industrial control processes are built to be both safe and then reliable. And then there's a sense of efficiency. Why were the systems converged? Why were they interconnected? Some of it was safety. That way you don't have to have an operator next to a dangerous process, physically hitting buttons or a lever. But a lot of it was under reliability and productivity. The key thing here that is very different than enterprise is that access at any level of these control surfaces equals control. There are no authentication mechanisms typically. Now I'm talking about lower in the stack industrial. Windows boxes still have passwords and logins, full stop. But the industrial processes, especially on the network layer, you're talking about TCP 502, which is Modbus, you talk about any of the protocols, they often lack either authentication, verification, they're not encrypted. And so when you talk about interacting with that network control surface, if you have access to it, you have control over it. Now, caveat, there are exceptions to all these rules, and I'm not looking to propagate any myths on, oh, it's all insecure or whatever, because again, the idea was it was designed and built for safety, reliability, and productivity. So keep that in mind as we start to dive into some of the fun stuff on networks. I'll look at chat. No questions. Perfect. All right, so to geek out a little bit here. When I was a pen tester, it always started with a rules of engagement and identifying the different requirements. And as part of that, you would say, what is the IP space, or what are the devices specific, the networks, the subnets, et cetera, that are within my scope of work or my rules of engagement? Well, put on your attacker hat. They're doing the same thing, especially if it's targeted against critical infrastructure. And so they're doing this kind of network surface awareness or discovery to say, well, what are the surfaces from network or from IP space that I could use to exploit X organization? Now, one thing on the external side, so when we talk about public IPs, there's something called the autonomous system number. This is essentially through Border Gateway Protocol, BGP. This is how the internet knows who owns what and how to route to each other. Think of this as internal routes that you would have on your home network, maybe some NATs, everything else, but on a global scale. So if you want to know, hey, what IPs does Google own? You could go look up their ASN numbers and see all the prefixes that are assigned to Google. This is important because as I get into Shodan and Census and all the traditional things that we've done to discover industrial protocols on the internet, this always started from well, I'm going to scan the entire internet for Modbus and then see what comes back. Well, that's not really effective. There's a lot of TCP 502 out there that's not Modbus. There's also a lot of honeypots out there. And just because you get a response on 502 doesn't mean it's critical infrastructure online. I take an approach to work backwards, which I'll show in some of the demos. Let's start with a known group of IPs in the public space, my local utility, your local utility, et cetera, and see, and this is what you would do as an organization, see what exposure you have publicly on your IP blocks. So that's ASN. RFC, which I made a grammatical error there. So RFC 1918 is what we use for private IP spacing. 192, 168, 1010, 172, those kind of things that are typically used internal to enterprise and industrial on their private networks. So if you were doing an internal assessment to see what type of surface you have between IT and OT, you would look at your internal IP blocks. So just a quick differentiator there. Now, I mentioned a little bit, and this is something I could probably rabbit hole for a little while, but it's important. Critical infrastructure, even from the DHS terms, has started to become I don't want to say a watered down term, but we have these certain events like COVID, for instance, where all of a sudden infrastructure that is critical to the nation or critical to me starts to expand. My ability to go to the grocery store all of a sudden became critical to me. So food supply is a critical infrastructure. Logistics are a critical infrastructure. The internet connections, the tier 1 providers that we're using to do this amazing thing and interact globally is considered critical infrastructure. So this isn't just what we think of in our community as industrial control systems, like I mentioned, power plants, refineries, et cetera. Critical infrastructure from the government side has been blown wide open to include almost everything at this point. So when you see presentations or social media posts or blog posts that say, oh my gosh, there's all this critical infrastructure on the internet, take it with a grain of salt and a little bit of consideration that just because you find a control surface like an HMI or an OWS or a network protocol like 502 Modbus, it doesn't necessarily mean it's critical. And so think about this even internally. What is critical? What is the internet? And really the important part is how many hops are you from your critical systems? Because a critical process that's connected to your enterprise, if it's one hop from the internet and that enterprise is not properly secured, user access, et cetera, then for all intents and purposes, it's connected to the internet. It's just an extra step. So keep that in mind as we talk about critical infrastructure. And I'm going to look to debunk a few things here with the Shodan and census stuff, but just quickly going through a demo. We might have some Q&A. Let me see. Can you please suggest use good user access mechanisms tips that should be generally integrated? Yep, I'll get to that one later. Oh boy, Disney ride with Alan Bradley. Stuxnet. We mentioned Stuxnet, so we have to drink now. How would you keep? Oh boy. Okay, so these two questions are really good because they're both getting to the concept of, regardless of what the threat actor is or what the, I would say, downrange exploit or concern is, whether it's exploiting a system, using automated or malware like Stuxnet, like a InDestroyer, those kind of things. The segmentation or the awareness of user access is important because, again, once you have access to that control plane or that control surface, then there are very few other mechanisms to prevent and acting on objectives, which is the last step in the kill chain. So I'll get a little bit deeper on that as we go, especially around the user access as a good practice. So to take a step here, if you haven't heard of Shodan at this point, amazing. John Madley does a great job. And I want to say at this point, and maybe, overly dating ourselves, it was probably 10 years ago at this point that I remember John presenting this to an ICS-GWG and the New York Times article of, this is evil Google. It's the evil search engine for everything that's not websites. But what Shodan does is brilliant. Crawlers around the world are interacting and scanning the internet and enumerating the services, the ports, the location. He's doing vulnerabilities now, tagging, all this amazing stuff to essentially do all of those first steps you would in discovery and enumeration, either as an attacker or as a cybersecurity professional. And this is all available on Shodan.io for you to have. There's different tiers of access, but just a wealth of information that you should be using as a cybersecurity professional, but that your attackers are sometimes using. So we're going to go over that, and then Census, which is another version of this. And there's a few other, I would say, not differently hosted, but there's one out of China. There's, people have now copycatted Shodan to provide this capability. So I just wanted to show you a few examples here as I've been talking about the network control surface. One is, and I love maps, so I'll show you this later. A little bit about ASN, again, autonomous numbering system. If you go on to something like a Hurricane Electric or any BGP toolkit, you can go on and search just as a query, and it'll provide the feedback on the description type. So I just threw in power and light. Here's some examples. The AS number is essentially the group number. And then as you scroll down, they actually break it out. Here, sorry for the quick scrolling. Then they'll break it out as to IP segments. So these are the actual class Cs, class Bs, the /24s, whatever it is that are assigned and owned by these organizations. And what I would highly recommend, and a lot of folks don't really know this, whether they're an enterprise or cyber, is just to be aware if your organization owns IP blocks. This is your publicly communicated and publicly available attack surface from a network side. So good thing to know. Now, you can then take that information and put it into a Shodan query. And Shodan's great. I'm going to try to make it a little bigger so we can see. Oh, click. Sorry, I'm on a Mac. There we go. So Tennessee Valley Authority, they're my local utility, but they're a big utility. You can actually go through in Shodan and not only query on ports or countries or some of the services, some of the traditional things you may think of using Shodan, but you can actually restrict it to ASN numbers, which is great because the ASN number, the group itself, could contain many, many, many class Cs, Bs, and As from a prefix stance on network IP space. And just makes this so much easier to go through and say, let me see all of the available IP space from Shodan's perspective for this organization. So when you think both externally or internally, this is a great way to, I call it tightening the concentric circles to get you relevant data about your system that you need. And then you can go through and see, and there's a few other examples here. For queries, I love Shodan images. Here's port 5900, which is of course VNC. We could go through and do 3389, which is RDP. Here, I was doing some searches earlier. We'll do that. But these are ways to interact with this network control surface and see what is actually available to the user, both internally and externally. Some other examples, you can overlay some maps, which again is powerful if you're using a search query for ASNs to be able to again see the specific relevant data for you. So good stuff here. Let me can't see. Wait, oh, I gotta drag this. Apologies, my Zoom screen's in the way. There we go, perfect. So example after example after example, this is all great stuff. And this is how you can see both your own organization's external IP exposure and then start to map that to your internal IP exposure. Now, census, same thing, you can search for ASN. Census, you can do, I would say, more computationally heavy type of queries where essentially you can search for this particular ASN and a port and a country and that is just really heavy computationally, but that's something they support and something you can go through and see. Now, it's always interesting when you do demos, like I chose these at random, knowing that, you know, nobody likes to be targeted or shown, but again, trying to kind of pierce the veil on the myth of, well, there's nothing available online. This is how it works, right? We all have public IP space, it's available online. And what you're looking for in here are those remote services, those industrial control services, the port 502s, the 3389s, to understand what is your exposed attack surface to the public internet. And just some more examples here. So that's a general overview of Shodan and census. I really love starting from I would say a point of ground truth. So if I'm working at an organization, it's Ron Power and Light, and I know that I own a Class C and it's publicly available, I don't need to scan the entire internet for 3389, 22, 502, 20,000, et cetera. I'm just concerned about mine. So I can use these tools that are at my disposal to essentially keep an eye on what my exposure is. And I wanted to show just another plug for Shodan. I love Shodan, and everyone should love Shodan too. Go like, subscribe, hit the bell. And depending on my internet connectivity, John has created a capability called Monitor. It's a pay-for service. Oops, set up Monitor. I won't go through all this, but the idea is that you as an asset owner could go in, or really me as anyone, can go in, pay for this service, and set up Shodan to monitor a certain IP block and then send me alerts, you know, send me information on, oh, here's how many publicly available IP addresses are today. Here are their services, et cetera. Great tool, and really use the tools that are at your disposal to do good things, not just to find funny open webcams online or RDP sessions, which is what people typically use it for. All right, let me pause here and look at Q&A just real quick. So can you elaborate on IP blocks? For instance, we all interact through Google, and a lot of Google DNS, they're on an 8.8.4.4. And so what that means in an IP block vernacular is that Google owns, I believe, the class B on that. So when you look at octets, 8.8.4.4, the first two octets are 8.8. And we can look this up, so if I'm mistaken, I apologize, but 8.8.0.0/16, they own all of the IP space there. So if you see 8.8.5.5.6.6.7.7, that's owned by Google. So this is a good way to know internally whether you're seeing traffic there or you're trying to figure out the exposure of your own services and IPs online. You know for sure that that IP address is attributed to Google. When we get into some industrial environments, the reason why this is important on IP blocks is that you also have the other IP blocks of, it's just a device hanging off Verizon Wireless. So Verizon Wireless or AT&T or whoever owns that IP block, but you don't really know who owns the system underneath because there's this abstract layer. You'll see this a lot in IoT research or in, I would say, C2 research. when it comes to devices that are phoning home to, the evil, countries. But really what it's phoning home to is an AWS instance in Ashburn, Virginia. So you see the IP block, that subnet or that octet and grouping of IPs, and it goes to an owner, but that owner may be AWS instead of, evilnation.com. So that's really the IP blocks. And then internally, your enterprise systems and your industrial systems are broken up into subnets, subnetworks, and those can be broken off into /24s commonly, which is your 10.10.1.0, and then you get all 254 IPs within that /24. /16 is the next octet up, et cetera, et cetera. So that's just a little bit on IP blocks. All right, let me go back. Perfect. So when we talk about hops, I think a common misconception, one, is that critical infrastructure is on the internet. I would hypothesize that while there are a lot of instances that get demonstrated of here's an HMI, here's an industrial system, or here's an industrial protocol that's exposed to the internet, 9 times out of 10, it's not critical. There was an example of a threat actor group where they said, oh my gosh, look at this. We found this HMI to a water treatment facility. It ended up being like a hotel pool, chlorination thing. So it was something that shouldn't have been exposed to the internet and but was that critical? Yeah. So again, keep that in mind. There's a lot of exposure to enterprise when it comes to services out of the nature of what enterprise IT/OT convergence needs to accomplish from a business sense. So when you take that into consideration, the one that's easiest from an operational stance to discuss is historian data. A historian is a time series database that keeps all of the different endpoints and control and all the data, all the telemetry needed to then put it into a time series database. And that way you can look back for troubleshooting, et cetera. But it's a very operationally focused database. Oftentimes, 9 times out of 10, that historian is hosted within the industrial control system network. Now, at some point, businesses said, hey, it would be great if we peered that data to a business HMI, or I'm sorry, a business historian, so that way we could use the same endpoint data telemetry for business analytics, efficiency, productivity, et cetera. So when you think of that now, if that's your only exposure point, then great, you're winning the game. But that historian point-to-point connection is going through a firewall, hopefully, and it's two-way, and it's providing data, very useful data from operations to or from operations to enterprise. And it's this one hop into your industrial network. Now, hopefully it's protected, et cetera, but you have many, many examples of these either 1, 2, or 3 hops before you get to critical infrastructure. And a lot of them have to do with either system-to-system access, third-party access, or even just normal user access. And so oftentimes when you think of exposures, it's not just exposures to the internet. That's the worst case. You don't want anyone going on Twitter and being like, haha, I found your hydro dam control system online. But think one layer deeper. How is that HMI, how is that control surface being accessed both at a local control center, physical layer, the Windows box, right, with the HMI? How is it being accessed internally, whether remote for you is from the enterprise or it's from a secondary control center? These are all things where you now are extending the logical access of that control surface to someone else. And then think how many hops away is that going if you're giving it to third parties, vendors, OEMs, MSSPs, all down the board. So very, very important. You will hear folks say, and I don't know if I necessarily agree with this, but if it's controlled to enterprise, and essentially it's controlled to the internet, but there are a lot of enterprise cybersecurity controls inherited for user access and network segmentation, et cetera, that can be inherited through that control, but it's something to consider. I would say 9 times out of 10, and 8 times out of 10, all these statistics are made up on the spot, but 9 times out of 10, whenever you hear of an attack that happens to disrupt industrial, the key connecting tissue is some sort of logical access to the system. We do have instances where it's like, oh, they created malware but it wasn't really malware to exploit for the purposes of gaining access. It was to automate the acting of objectives on the control system itself. the threat actor is still gaining access to the system and then doing whatever they want. So whenever you hear of, and apologies if anyone's playing games at home, but when you hear of Stuxnet, you hear of Colonial Pipeline, you hear of these things, the common thread is, well, they got access through a VPN that no one knew about, through a reverse proxy, through a firewall rule that should have been closed because it was up for maintenance. That's the connective tissue here. So your exposure to enterprise is as important as your exposure to the internet. All right, so flows. I had mentioned before that access equals control for industrial. And again, that's broad strokes. There's edge cases and contradictory cases to that all over the place. But for normal operations, it's the flow of access between operator and control surface, through networks, through systems, et cetera. There may be even access flows under normal operations between IT and OT, like I mentioned the historian example. There are other examples where that's just normal. There's no anomaly detection. There's no IOC that's going to say, oh, wow, I saw a connection between IT and OT, red flag. A lot of this is normal to operations. So understanding the state and the state changes is critical in understanding who and what has access to your control surfaces. Another key thing that sometimes I would say traditional cyber folks forget is that these systems will go into either downtime, emergency operations, things that change the state of these access surfaces. For example, if you're on an oil rig in the Gulf of Mexico, you have a normal control surface. You have systems, they're interacting. You have folks on the rig that are using the access that's there for them locally. What if a hurricane is coming up and they have to evacuate the rig? A lot of times they're not actually shutting down processes. They'll go to a remote operations model or a state change until that condition, that hurricane or that emergency condition is satisfied. So even though conceptually we all think you should never have remote access to critical infrastructure or cyber physical processes, or things that could go boom, but there are normal or emergency or states in operations that can and do allow this. And in fact, they should allow this. So backup sites, remote access, or secondaries that become primaries, even in downtime when there's a maintenance turn, the control and access surfaces will change because more third parties are in, more vendors are in. They may even open up remote access because now the process is no longer running. They could open it up to a vendor to do upgrades, do diagnostics, et cetera. The trick is when they go back to production and normal operations, are they shutting down those attack surfaces and flows? That's why when you hear about these different attacks like VPN, firewalls, kind of traditional user access controls, which was another question in QA, what are some of those traditional controls? It's not that they're necessarily bad for OT, it's that they're easily forgotten or exploited when you have a physical process associated with them. So again, access is critical to operations. The level and the changes of access, whether that's local only, remote in the sense of control center, or even just third party like internet remote, all of these things are on the table for an operational stance. All right, so I've been going on for a little bit, on the overview. So what steps you can take? Really, I would start from a boundary level. You do have the internet to enterprise. And if you're a cybersecurity professional, if you're an industrial control system cybersecurity professional, knowing the exposures of your enterprise IP blocks, what they own, what that boundary looks like, is useful information. Because if you can go on to Shodan, if you can go on to Census, if you can set up these Shodan monitoring, these tool sets to automate your job for you, you want to be the first to know if you have an HMI that's available on Shodan in your IP block. You don't want anyone else to let you know. You don't want the FBI calling you. You certainly don't want a security researcher going on Twitter and posting screenshots. So being aware of this is something you can do. But when you go deeper, really we're talking about that internal boundary between industrial and enterprise. And at this point in the modernization and the convergence, or whatever you want to call it, there are, I would say, cybersecurity controls in place. There is a boundary now. You may still hear edge cases where it's a flat network and there's email systems, whatever. That's usually not the case anymore. There is some sort of boundary, which means there's some sort of configuration that you can review. So I'm big on architecture reviews. They're low resource. It's looking at the documentation or the systems you already have in place, which is a great way to identify the gaps you may have in your documentation. But it's also just a way to see, again, how these access surfaces interact between IT and OT. You can look at the firewall rules, see what ports and services are allowed through the firewall to get to your critical infrastructure. That's that exposed attack surface for your infrastructure. You can look at the ACLs. You can do all these things. And although I don't work for them, I'm a big fan of being a fan. And network perception I was using as a consultant years and years ago. This is one of those tools like Xona that you can use to automate and feed in your firewall rules and to basically give you a visual representation of where all these routes go, et cetera. So quick plug for them. They're awesome folks. Go check out their tools. Same thing with Xona. But there are things that you can do now in a non-technical kind of architecture assessment to just get a grasp on what your attack surfaces are and to see and discover without doing scans, without doing any of the messy kind of risky stuff, to see if there's any exposure at all that's possible through the configuration of your boundary. Another one is just general awareness. You'd be surprised, this surprised me every time as a pen tester. While it may not have been part of the rules engagement, you would go through a typical research period. You know, who am I attacking? What's their processes? Where are their facilities? A lot of folks just don't Google themselves anymore, which is kind of a funny concept. They don't show that in themselves anymore. They don't actually just see what's publicly available about the exposure, not only technically, but from the people and the process, et cetera, about their critical infrastructure. So Googling, if you're a power generator, just see what information is out there on your power plants from the internet. Go on Xona, go on social media. You'd be surprised at what your employees post in Facebook groups online about the inner workings of their power plant. Going into LinkedIn, this is especially prevalent, I would say, outside the US, but technicians that work on the relays, the PLCs, et cetera, they'll have qualifications. They will put on their LinkedIn exactly down to the model number firmware of what they're qualified to work on. And if they work for an asset owner, you could rest assured that that's probably the exact make, model, firmware number that they're using in their production environments. So the key there is there's a lot more information out there than you think. This isn't really an OSINT talk, although I love talking about OSINT because it's a critical piece of context when we talk about exposed services. It starts to bring in that, again, concentric circle of not only is something exposed, but here's all the context I know about it. And I know Ron's a technician and he works on, S7 1200s. And so now I get my research and it just builds that attack profile. So as much as you can reduce or at least be aware of that surface, it helps contextually with that issue. All right, we had one chat, one question. Perfect. Let me close that before I go in. No open questions. So before I summarize, I did want to, and I hit on this point earlier, especially when you're new to cybersecurity and industrial, the first thing you think is, well, no one should have remote access or no one should have access to these systems. Why on earth, Ron, are you talking about enterprise access to critical infrastructure or third-party access to critical infrastructure? A lot of people don't know about the GE Atlanta Data Highway, right? I think they've rebranded it. A lot of people don't know that OEMs have this remote access direct to the turbine. It's not about stopping the access. In the same way that if you're in vulnerability and patching and maybe even SBOM, you hear a lot of things like, well, haha, they're still using Windows XP. I would posit that we've not lost the battle, but we're missing the big picture on what does operations need. If they need that Windows XP box and they need their vendor to be able to access it, I'm kind of the point in the industry now in the community, we need to say, okay, we're going to stop telling you no, we're going to start telling you how. So it's not about stopping the access, it's about safe and secure. So the pitch for Xona, and I'll keep this very brief, but the way that we can provide this glove box level disruption gap between untrusted and trusted networks, whatever the case may be, whether untrusted is the internet or untrusted is enterprise or untrusted is the backup to the primary, you want to be able to control and isolate how users interact with those critical infrastructure assets. And what Xona has and what we provide as the CSG critical security gate or systems gateway is that interactive layer that isolates everything on the trusted side from the untrusted side. And it gives, and I've been working a lot in pharma and biolabs lately, where you have those isolation boxes and the gloves, and you put your hands in and you interact with the thing without actually interacting with the thing. This is taking that concept and applying it to logical access, which is exciting because it's not revealing more problems for our operators. It's solving a big one, which is they need this access, which is why you have the VPNs that people forget about, which is why you hear about people using TeamViewer. It's out of necessity. So let's give them something that makes their operations more safe, secure, and accessible in the ways they need to be accessible. So that's the excitement. And that's why I love taking my previous experience with exposing attack surfaces and then lining up with, oh, and then here's something you can do to provide access for those operators without introducing or really with reducing the risk to the overall system. So summary, and we have some more questions coming in. Beautiful. So in summary, want to go over, and I have a link too, because just as a tangent, the BRISAC someone had posted this generator on essentially creating like warning and notice signs that are ANSI compliant, which I love things that are overly formal and compliant, but then are funny. So just to summarize, attack surface for us as cybersecurity professionals and industrial cybersecurity professionals isn't necessarily about attack, but it's just surfaces in general. There are so many different control surfaces, whether that's systems, networks, or people, that have to be there in order for operations to succeed. Now, in industrial security, that typically means that access to those surfaces equals control. There's very little in the way of security authentication on protocols, encryption, et cetera. So once you have network access or system level access, no exploit required, right? There's nothing that you necessarily need to do to disrupt operations in our critical infrastructure. And that's, again, by design. They're designed to be safe, reliable, and productive. Again, power plant managers have told me, Ron, I'm not here to make the cybers. So fair. Now, exposure, though, of these control surfaces can cause disruption. And this is where really you've seen the boom in industrial control system cybersecurity, is that now that we have increased risk, increased attack surface, and the user access and the system access is still there, this exposure does directly hit their safety, reliability, and productivity, or at least it can. And we've seen some evidence of that either in malware, threat actor campaigns, or what I call ransomware splash damage, where you have something affect enterprise, it then is exposed, or industrial is exposed to that, and then there's a disruption in operations. Not just about finding stuff on Shodan and the internet, but the exposures are for sure coming from inside the house. They're coming from within your enterprise systems, within your local facility networks. And just know that, again, you have these different boundary levels to look at and the different exposures at each boundary. Some systems are even nested even further. So take that into consideration as you're looking at your attack surface. Access, again, is critical to operations. So you got to stop telling operators, no, you can't do that. It's how can you do that in a safe and secure way? And that starts with awareness. That starts with getting a handle on what your exposed services, your exposed control surfaces are, and then being able to have that conversation with the operations group to say, we want to enable and empower you to do your operations safely, reliably, securely. And this is how we can come alongside and do that. So here's the link to make these warning signs, which I absolutely love. Hopefully you can all see that. If not, I'll post that on Twitter or LinkedIn, et cetera. It's an effective tool. As much as you can use the vernacular, the theming to relate to our operational groups to get these points across, the better off you'll be in your communication. So I just love that. So with that, Mary, I don't know if you've seen any other questions, but I have a few here that I can go into.
I know those are the only questions I see right now.
Awesome. So a few other questions. You said maybe even a comment, someone could use all this essentially to piece together a very bad attack on your control surface plane. And that is, I would say, when you look up a series of technologies called attack surface management on the cybersecurity side, that's really what they're looking to monitor, right? Is how can bad actors take this available information and chain them together in the kill chain to then go act on objectives. That one's definitely a consideration. And then, Sumit Bhai, so good to see you. And I'm so glad that that we both have US and international folks joining in. This is really a community effort, and just keep in mind that our community is much more broad than even the SANS community, but even the cybersecurity community. It's coming alongside our operators. It's helping them in this journey and giving them effective tools and techniques and ways to continue operations. Because, and the reason why I include the picture of my family, like, this is why I do it. This is why you should do it. This is so much more than Netflix going down on the weekend. Although for my family, you know, like I was saying before, Netflix is sometimes critical infrastructure. So I get the tier 1 phone call. Why is Netflix down? But this is why I'm so excited and passionate about doing this. This is our power. It's our water. It's our food. It's our way of life. And this is why I do what I do. And hopefully you've been able to take away something from this. If you have any questions, you can hit me up, ron@xonasystems.com. I'm on all the social media, and I'm here to help you. So thanks again for your time. And I really appreciate Mary for SANS hosting us.
Thank you so much, Ron, for your great presentation, and to Xona Systems for sponsoring this webcast, which helps to bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.